Alright, we're now given a slightly harder tension problem, which involves a 30 kilogram mass being suspended from the ceiling by two cables, one making an angle of 60 degrees with the ceiling, and a second making a 45-degree angle with the ceiling. What we're asked to do is to calculate the tension in the two wires. Again, the wire's mass is negligible. Alright, what should we do? So let's start with a free body diagram. Do it right here. So we have force of gravity, Fg. We also have our first tension, tension 1, and we have our second tension, tension 2. So we can find the force of gravity. In fact, let's do that right now. So the force of gravity, force is mg, where m is the mass of the object and g is the acceleration due to gravity, which is about 9.81 meters per second squared. So let's plug those numbers in. So Fg equals 30 kilograms I gotta find the magnitude of the force of gravity, alright? That means I'm not gonna put the negative for G. And that gets us, get out my calculator. Alright. 30. So let's plug that in your calculator. You should get about 294 294.3 newtons. So that's the force of gravity acting on this object. Alright, so now what do we do? Well, we know the force of gravity, so let's start from the y direction. Take the y components of these tension forces. I'm doing my best to draw a dotted line here. So that's our tension 2y, and excuse me if it gets a bit messy, a degree sign, tension 1y. So those are the forces holding this thing up. So we have the acceleration in the y direction. Let's just use Newton's second law. Acceleration in the y direction equals the net force in the y direction over our mass. So our object's at rest, so there's no acceleration in either direction. So you plug 0 here. Now, this force is going that way, this force is going that way. I mean, the vertical component both have to be going up. So, let's put that as positive. T1y plus T2y minus force of gravity right here, 294. 294.3 newtons over our mass, 30 kilograms. So we multiply this by 30 kilograms, 30 times 0 is 0. Then, so we get T1y plus T2y. Then if we add 294.3 to both sides, get 294.3 newtons. Sorry, that end was a bit weird. Right. And we have seemed to hit a roadblock here. We have an equation with two variables, T1y and T2y. And that's a problem for us, because we cannot solve it. Let's check the x direction and see if we get anywhere. Draw the x components right here. I'm going to draw them in red so you don't get confused with the box. So this is T1x, and this is T2x. So one's going to the right, one's going to the left. You're not going to just draw them stuff here, and you'll see that it matches up with the original vector. So they're both going in opposite directions. So let's calculate the acceleration. The x direction is to equal the net force. Net force in the x direction over the mass. And again, it's just 0. Equals T2x is going to the right minus, because it's going to the left, T1x. So the tension 1, the x component of tension 1, over 30 kilograms. 30 kilograms. And again, we have seemed to hit a roadblock. So multiply this, and you should get T2x minus T1x equals 0. Add T1x to both sides. You should get T1x equals T2x. Alright, so now we're at a problem. Why? Because we have two variables here, and two completely different variables there, so no system there. Well, what if we could write T1y and T2y and T1x and T2x in terms of the original vectors, T1 and T2. So what is T1y? So that's just opposite over hypotenuse. So that's just T1 times the sine of 60. Sine But you know what? I have a better idea. Let's go to the x. It looks much simpler. Plus T1x. So if you are here, so this is also T1x. If you are here, that's adjacent over hypotenuse. T1 cosine of 60. And what's T2x? T2x is, draw it right over here. So T2x is also cosine, is T2 cosine of 45. So now let's solve. Alright, T1 cosine 60. So that's just half of T1. T1 over 2 equals T2 cosine of 45 is root 2. Pick some easy angles, like 60 degrees, 45 degrees, so we don't have to get intimidated by all these decimals and stuff. But you might not be so lucky, so this is just a general way to solve these types of problems. And you get T1 equals T2 root 2. And then you might say, what's the point of that? Now, well, the point of that was, so let's put this in terms of T1 and T2, what I was doing before until I realized this bright idea. T1 sine 60 plus T, and this is actually tangible because now we put F, you'll see what I'm going to do it later. Sine 45 equals 294.3, and it works. Getting a bit messy here, but newtons. So let's plug T2 root 2 for this. T2 root 2 times what's the sine of 60? So T2 root 2 sine 60. Should have done the x's on the left, but who am I kidding? T2 sine 45 equals 294.3 newtons. So if you were to add this, you would get so that is equal to, so what's the sine of 60 times square root of 2? Let me use my calculator. Plus the sine of 45. I'm just doing is I'm adding this stuff together. And we get, if you simplify, like if you approximate square root of 2 in your calculator, approximate this, approximate that, then add these variables together, you should get, oopsie, I may have used the one. Alright, you should get 1.93 T2 equals 294.3 newtons. Divide that by 1.93. If you really want the exact amount, use the value stored on your calculator. So you have 294.3 over, and we get 1. So T2 equals 152.3 newtons. 3 newtons. Alright, let's plug that in here to find tension 1. So tension 1 equal to 152.3 newtons times root 2 and we get tension 1 equal to 215.4 newtons. And we are